I decided from a very early age that what I wanted to do with my life was somehow to make a difference, and that was what led me into science. And I decided that when I found that I was a reasonably good programmer, that computer science made sense. But the reason I did it was because I wanted to create artificial intelligence. I thought that it was a bit of a shame that we have to do all these tedious things like, going down mines and serving hamburgers and whatever, when we could be spending that time enriching each other's lives and doing what we enjoy. So that's why I went into that area. But then, while I was working in that area, I met, and eventually, very shortly afterwards, married a geneticist from California, who was doing a sabbatical here, actually. And over the next few years, I informally learned a lot of biology over the dinner table, and gradually began to realize that actually my wife, and indeed pretty much all other biologists that I was coming across, thought that aging was a really boring, unimportant, uninteresting area. And I was absolutely horrified. I had always presumed that biologists understood the obvious fact, it's obvious to me, that aging was the major unsolved problem for the world, and certainly the major topic that biologists should be working on. So, when I found out that that wasn't true, I eventually decided that this was even more important for humanitarian reasons than creating artificial intelligence, so I just switched fields. It's an interesting fact that evolution has vastly speeded up for the human race over the recent past. It has speeded up simply because we have been altering the environment within which evolution is occurring, in other words, the selective pressures. So one very conspicuous example is that the immune system of typical people is less strong than it used to be. The reason for that is because people with weak immune systems can get away with it. They are no longer selected out before they have their own offspring. And it turns out that actually women with a weak immune system are more fertile because they are less prone to rejection of the fetus being sort of mistaken for an infection. So that's just what's happened in the recent past. But if we look into the future, what we have to take into account is the advent of safe and effective gene therapy, ways in which we can alter the genetic composition of individuals who are already alive. And what that will do is mean that evolution astronomically speeds up even further, because we will be incorporating intelligence, human natural action, as part of the process of evolution. Of course, there are other aspects that will do that too, things like prenatal genetic diagnosis that's happening at the moment to help to eliminate important congenital diseases. So really, any idea that the elimination of the turnover of individuals through people living indefinitely would have any impact on aging is just very short-sighted indeed. Sorry, on evolution is very short-sighted indeed.
Because you're saying that in some respect you're taking charge of the evolution ourselves.
We have already really taken control of evolution ourselves, and that will become more and more true, and it will become completely true when we have safe and effective gene therapy. It's pretty clear to me that the way that we are going to achieve the defeat of aging is by regenerative medicine, by developing comprehensive approaches to the repair and amelioration of all the various types of molecular and cellular damage that accumulate throughout life as normal intrinsic side effects of metabolic processes, and that eventually get in the way when they become too abundant and start to cause the pathologies and diseases of old age. Fixing that damage periodically is a practical approach. We don't have to fix the damage completely, we just have to fix it fairly well so as to buy time, basically, so as to keep one step ahead of the problem. And I think that we are within striking distance, within a few decades, of achieving that goal in all respects, in all of the various types of damage that matter. Of course, that time frame is very speculative. It's a 50-50 guess. I think we have a 50% chance of getting there within perhaps 25 years. but I certainly think that we have at least a 10% chance of not getting there within 100 years if we get unlucky. However, a 50% chance is quite enough to be worth fighting for. So the question then is, what are the components? Well, that's really the focus of my work. The way that I normally describe it is that all of the various types of damage that we need to address can be classified into 7 major categories, within each of which broadly the same approach should work to actually repairing that damage. So, for example, one category is the death of cells not compensated by the division and differentiation of other cells. So, in other words, the gradual loss of the number of cells in a particular tissue. There are various aspects of aging that are caused by that. And what we need to do is basically stem cell therapy. We need to put the cells back medically when the body is not putting them back automatically. So that's the sort of thing. People think of aging as, natural. They think that it's inevitable. They think that it's something that we can never do anything about. But that's obviously crazy. 200 years ago, people thought the same about tuberculosis. And here we are, and not a lot of people in the Western world get tuberculosis anymore. And when they do, we fix it. It's just the same. At the moment, when I say that I think that we have a 50% chance or thereabouts of achieving this sort of decisive amount of progress within the next 25 years, I'm basing that on what already exists. I think that we're within less than 10 years of achieving the equivalent technology for mice. In other words, demonstrating proof of concept in the laboratory in a mammal, which will be a sufficient evidence that it's only a matter of time before we can do it for humans. Of course, we still won't know how much time it's going to take to go from mice to humans, but it will really convince pretty much everybody that it's only a matter of time. So less than 10 years is a much more, analyzable time frame. And that comes from taking apart each of these 7 things that I've been talking about, these 7 types of damage, and looking at the ways that seem to be available to address them, and then looking at what we can already do, how close we already are, what precursor technologies are already in place, have already been demonstrated. It's putting all those details together that leads me to a time frame.
These 7 steps you're talking about, you've written about, they all concern cellular events that happen within a human cell, aren't they?
Some of these events are things that happen to cells. So cells becoming less abundant because they're dying and not being automatically replaced. Cells becoming more abundant because they're not dying when they're supposed to. Cells becoming more abundant because they're dividing when they're not supposed to. Some of them are molecular events inside the cell, such as mutations accumulating in the mitochondria or molecular garbage accumulating in the lysosome. And some of them are events happening outside the cell, in the spaces between cells, such as, again, molecular garbage accumulating, things like amyloid, and also stiffening of the extracellular matrix, the network of proteins that basically holds our tissues together. So molecular and or cellular things. An enormous thing that I have to encounter when I talk about this work with other scientists is the difference of mindset between scientists and technologists. Science is all about finding things out for the sake of finding things out, and if it happens to be useful, then that's a bonus. But technology is really all about sidestepping our ignorance, about figuring out how to use the little information that we have for humanitarian gain, despite the fact that we acknowledge that there's an awful lot of stuff that we don't know. So it's certainly the case that there's a great deal that we still don't know, an astronomical amount that we still don't know about how metabolism works, how biology actually works, and indeed about how these various types of damage that I've been speaking about are created. But the whole idea of applying regenerative medicine to the problem of aging, in other words, actually periodically repairing this damage, as opposed to the more traditional idea of slowing down its creation, the whole idea there is that we don't need to know much about how the damage is created. We just need to characterize the damage itself, and then we can figure out how to fix it. I'm much more of a technologist at heart than a scientist. I really always think in terms of the overall goal. Now, that's not to say that I don't respect basic science. I think that it's completely clear that most of what we achieve in technology is built on the shoulders of work that was not done for any particular reason. It was done as basic science for curiosity. So I'm totally up for curiosity-driven basic science. However, I think that it's often the case, in fact it's very often the case, that the people who are the best at generating knowledge within basic science are not the people who are the best at identifying when they know enough, or when they don't know enough, to move forward and apply that knowledge for humanitarian goals. We know quite a lot actually about how these types of damage contribute to certain of the most major, most well-studied types of age-related disease, but even there we're still fairly ignorant. There are still lots of hypotheses, for example, about which of the types of damage that we see in Alzheimer's disease is actually causing it and which of them are side effects or adaptations. But we don't need to know any of that either, because if we restore the structure, the molecular and cellular structure of a tissue and of the whole body to more or less how it was as a young adult, then we know that we're going to be restoring the function as well. It doesn't matter how that function actually comes about, and part of the function is, of course, the longevity. It is very, very clear that there is not anywhere near enough money in this area. And I am not the only person saying this by any means. Basic scientists who work on the development of new knowledge about the biology of aging are saying exactly the same. Everyone who has paid any attention to why people get sick and how much it costs are of one voice, that it would make sense to spend hundreds, maybe thousands of times more money than we currently are on figuring out what's really going on with aging so that we can delay it. Even a small amount of delay in the age at which people begin to suffer the frailties, the disabilities and diseases of old age will make an enormous impact on the economy. In fact, already the increases in longevity and, of course, healthy longevity that have occurred over the past few decades as a result of medical advances against atherosclerosis, for example, have had an enormous economic impact. When you talk to people about the idea of combating aging, they constantly fixate on the fact that it would mean that people would live longer, and they think about all the changes to society that would need to occur, and they think about all the difficulties that there might be in actually making those changes happen without side effects, so to speak, without bad consequences. And they just forget completely about the fact that, hello, we have a problem today, that people get sick, they stay sick for a long time and then they die. You know, hello, that's quite bad. You know, people just forget it. It's extraordinary. If you're sick, you're sick. It doesn't matter how old you are. There's no such thing as being healthy for your age. You know, and if we reject the concept of ageism, if we say no, old people are people too, then sick is sick and healthy is healthy, and never the twain shall meet. The key point about all of this is that the longevity benefits of combating aging are not the point. The longevity benefits are a side benefit. The point is keeping people healthy. It just so happens that if we keep people really, really healthy, so healthy as young adults, then, lo and behold, the chance that people will die in their sleep at the age of 90, any particular night, is no different than the chance that they would do so at the age of 30. In other words, it's very small indeed. If we ask about pensions, you know, why do we pay pensions at all at the moment? Why do we pay people from the age of 65 to do nothing? The answer is we do it because we're very sorry for them. And we're very sorry for them because they're about to die. If that's not true anymore, then the whole social contract has to be, you know, redesigned. I mean, of course, already we have the situation of recognition that people aged 65 or 70 today are considerably healthier than people of that same chronological age were 50 years ago, and therefore that it makes sense to get people to work a little longer so as to pay for the pensions that they will eventually need when they don't get so healthy anymore. I think that it's a very good thing that there are people like me working on the wet biology of aging, trying to fix things up using something that would be effectively an extension of existing medicine, as opposed to also other people working on alternative, what we might call non-biological approaches, such as uploading or even creating artificial intelligence that could speed up the development of therapies that we're too dumb to be able to develop quickly, and thereby saving lives that way. So, there are a number of people working in artificial intelligence for the main reason that they don't quite trust me and my colleagues to be quick enough to save enough lives, and they'd like to speed things up using machines. I'm very, very pleased that that's happening. I don't know whether it's going to work. I don't know whether these people will be able to generate computers that can speed up the development of new technologies, but maybe they can. Likewise, I don't know whether nanotechnology and uploading and other non-biological scenarios will actually be developed more easily and more quickly than the approach that I'm pursuing. I'm only interested at the moment in trying to stop people from getting sick and therefore from dying as a result of being sick. I'm not working on stopping people from being hit by trucks. And from the point of view of someone who is worried about how they would think about themselves or how society or humanity would think about itself in the absence of death, one has to remember that we're not talking about the absence of death. There will still be death in a post-aging world. I think that this is just one example of the spectacular array of irrationalities that people tend to adopt when they think about this problem, when they are forced to think about it. And the key thing here is forced. I think the fundamental deal is that people really, really badly don't like to think about aging because they know that it's ghastly, and they know, or they think they know, that it's inevitable. And while it really was inevitable, that was perfectly rational, because, what are you going to do if there's this terrible thing that's going to happen to you in the future, for most of us in the relatively distant future? Are you going to spend your life preoccupied by it, getting you down, or are you going to try and find somewhere and put it out of your mind and get on with your miserably short life and hope for the best? And of course, that latter approach is the thing to do. And exactly how you put it out of your mind doesn't really matter. It's perfectly okay, perfectly rational to engage in the most egregiously irrational rationalizations to just stop thinking about it and convince yourself that aging is actually quite a good thing after all. But now that has become an enormous part of the problem, because aging is no longer inevitable. We are in a position in striking distance of developing technologies that can defeat it. And the more we try, the sooner that will happen. And the more we continue to fixate on these irrational myths about the desirability of aging, the less we will try. So that's something that I have to spend a lot of my time fighting against. So when we look at mammals, it turns out that mice are the species that's been used for the longest across the whole of biology, and so there's a lot of tricks. There are a lot of things we can do with mice that we just can't do with any other mammalian species at this point. So that's useful. Another reason why mice are useful for all of this is that they are mammals. They are relatively similar in body plan. They have more or less the same organs that we have. If you do experiments in fruit flies, for example, you really don't find out things that are as relevant to the detailed biology of aging in humans as you will if you use mice. Now, another feature is longevity. If you've got some sort of intervention against aging, then you need to show that it works. And the way you show it works is by taking your animal of choice and making it live longer than it otherwise would. But if how long it otherwise would live is quite a long time already, then that's a long experiment. It takes time to get your result. So, of course, we like to use short-lived species. And that means that mice are, in that respect, less valuable than fruit flies, because they live a lot longer than fruit flies. But they only live a couple of years, so it's a great deal more preferable to use mice than it is to use, chimpanzees, for example. Quite apart from any ethical issues around using animals that are so close to humans. So those are the main reasons why mice are so popular. And so this milestone that I defined a few years ago, called robust mouse rejuvenation, I said, what we need to do is we need to take a bunch of mice that are of a strain that already lives unusually long. So we can be sure that they have nothing congenitally wrong with them and that we're just fixing something easy. We can be sure that if we extend their lifespan, we are actually hitting aging. So really we need mice that live an average of 3 years. Then we need to ensure that the interventions that we do can be applied late in life. So we need to do exactly nothing to these mice, whether genetically or pharmacologically or in diet or anything, until they're already middle-aged. So I've said until they're 2 years of age, and they've got 1 year to live. And then in terms of the magnitude of the result, what I've said is that for what we can call robust mouse rejuvenation, we should not just extend their lives by a week or a month, we should extend their lives by 2 whole years. And furthermore, of course, that extension of life should be extension of healthy life, so that the 2 extra years are lived in good health. It's very, very important always to remember how little we know about how the body really works. The reason why any medicine that we have today only works for a subset, typically less than half of the people who ostensibly seem to be appropriate for it, is precisely because we just don't know enough about how the body works and therefore how to manipulate it medically. And the same is true for supplements, the same is true for all micronutrients and so on. Of course, there are plenty of ways to shorten your life by doing things that you shouldn't do, smoking for example, or having a restricted diet, for example a junk food diet that is lacking in a bunch of micronutrients, or we're not getting enough exercise so that we put on too much weight. But you knew all that, right? So as long as you just stick to those things, the question then is what can we achieve with modern knowledge? What can we achieve using more high technology dietary manipulations? And the answer is, as far as we can tell, pretty much zero. We might conceivably make a small amount of difference, a few months, maybe a year, but it's just not going to be the holy grail of combating aging. And I don't object to a few months or a year, that's better than nothing. So I don't tell people they shouldn't take supplements if they do it intelligently and so on. I just say that unless you are one of those unlucky people who are going to be aging unusually fast and dying unusually young, this is just not going to make much difference to you, and you should not get it out of proportion. When I've been tested, which I have a few times, really high-end tests of my metabolic state, 150 different things in my blood, lots of cognitive and physiological tests, I always come out really well, like 15 years younger than I actually am. Right. So for me, the opposite situation is the case. For me, it's a case of if it ain't broke, don't fix it. In other words, even if there were a supplement or some other dietary regimen that had been proven unequivocally to be beneficial for most people, even then I would have to be cautious about actually adopting it because I'm already not the average person. One thing I want to repeat and emphasize is that I don't really think very much about my own longevity as a motivation for how I live my life or what my lifestyle is. It's really only a peripheral aspect of how I think about things. But of course I do, I look both ways when I cross the street, just like anybody else does, because I definitely want to carry on doing what I'm doing, making a real difference to the future of humanity. So I do some things, but they are things that predominantly guard against imminent death. I wear a seatbelt even in the back seat. I don't accept seminar invitations to dangerous countries, things like that. In terms of my health, in terms of the rate of aging, since things are going so well for me already, since my biological age seems to be not keeping pace with my chronological age, I feel very happy to simply carry on doing what I'm doing. I eat and drink what I like. My wife's a very good cook, and so I end up getting a good, varied, balanced diet, at least when I'm at home. And that seems to be enough to keep me healthy and keep me going. I always say, actually, when people ask me for advice, I always say, well, look, the thing that matters most is not to generalize, not to just read a book and say, okay, I'll do that, but rather to actually listen to your body, to do what your body seems to be happy with doing. I am extraordinarily privileged to have the life I have. The fact is that virtually nobody in this world gets the chance to actually spearhead the thing that they regard as the world's most important mission, and that's the situation I'm in. So I'm extraordinarily lucky.
So you do enjoy life to the fullest, don't you?
I have to tolerate the brutal schedule that comes with being a prominent figure in a prominent area. Obviously I travel all the time, It grinds me down to some extent, and I always have an enormous email backlog. You know, it's a little bit pressurizing sometimes. But the fact is, I'm doing it because I want to. It's my own fault, and so I certainly don't feel bad about it.